Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we will be discussing some definitions and terminology related to Module 5, that is, on sequential circuits fundamentals. So we all know what is sequential circuit and what are the major differences between combinational and sequential circuits and what are the various types of sequential circuits we have, and we'll be discussing some basic terminology and their definitions in this lecture. So first of all, what is a counter? So counter is a sequential circuit which counts the pulses which are driven by a clock signal. So that means it is a sequential circuit, or else we can also call it as a digital circuit, which can count the clock pulses, or else which can count the event, or else the number of occurrences of an event. So is known as counter. What are the categories of counters? So the counters are how many types of counters we have. So basically counters are of two types, that is synchronous and asynchronous counters, and they are also said to be single and multi-mode counters and modulus counters. These are the various types of counters. First category is synchronous and asynchronous counter and single and multi-mode counters, and the third category is modulus counters. So these are the different types of or else categories of counters. What is a multi-mode counter? What is meant by multi-mode counter? If the same counter circuit can be operated both in both the up and down counting modes, then it is called as multi-mode counter. So if the counter can count in the incremental order or else in the decremental order, then such type of counter is said to be multi-mode counter. What is asynchronous counter? So a counter is said to be asynchronous counter. So when each flip-flop of the counter is triggered by the previous flip-flop. That means the output of one flip-flop is taken as the clock input to the next flip-flop. Then such type of counters are said to be asynchronous. As you all know that counters are formed by cascading number of flip-flops. So these are the flip-flop stages here. So each flip-flop will be having a clock and their inputs here. Inputs are also there. So for example, if it is a JK flip-flop or else T flip-flop or D flip-flop, whatever it means is the type of flip-flop. So if the output of one flip-flop is taken as the clock input to the other flip-flop, then such type of counter is said to be asynchronous counter. So you have to remember the counters are constructed or else implemented using flip-flops. That means cascading the flip-flop. Cascading in the sense the output of one flip-flop is given as input to the other flip-flop. So while giving this output of one flip-flop to the other flip-flop, if the output is given as clock input to the next flip-flop, then such type of flip-flops are said to be asynchronous. Or in another way, if all the flip-flops are not triggered with the same clock pulse, then such type of counters are said to be asynchronous counter. That means all the flip-flops are working with different clock pulses. Such type of counters are asynchronous counter. What is a ripple counter? Ripple counter is also known as asynchronous counter, where only the first flip-flop is applied by the clock whose pulses are to be counted, whereas the output of first flip-flop is given as clock input to the next, and so on. Such type of flip-flops are said to be ripple counter, and ripple counter is also said to be asynchronous counter. So we can say that ripple counter is another name for the asynchronous counter. So what we are doing, the clock pulse whose pulses are to be counted or given as clock input to the first flip-flop, whereas the output of first flip-flop is given as clock input to the second flip-flop, and the output of second flip-flop is given as a clock input to the third flip-flop. So like that, so the output is connected as clock input to the next stage flip-flop. Such type of flip-flops are said to be ripple counter. Where the ripple counters are used, explain. So what are the applications of ripple counter? So ripple counter is used for frequency division operation, time measurement, frequency measurement, and distance measurement, and also for generating square waveforms. So these are the major applications. So we can use this asynchronous counters as frequency divider and time measurement device, and also frequency measurement and distance measurement. And these are also used for generating these square waveforms. What is the difference between ripple counter and synchronous counter? So, as we all know that asynchronous counters will not, in asynchronous counter, all the flip-flop will not work in synchronous with the same clock pulse. All the flip-flops are applied with different clock, whereas in synchronous, all the flip-flops are applied with the same clock pulse. That means all the flip-flops in synchronous counter works in synchronous with the same clock. So that is the major difference between the ripple counter and synchronous counter. So in ripple counter, the flip-flops are triggered with the different clock pulses, whereas in synchronous counter, all the flip-flops are triggered with same clock pulse. What is a major disadvantage of asynchronous counter? So the major disadvantage of asynchronous counter is an extra resynchronizing output flip-flop may be required. That means while applying the one output of one flip-flop to the other flip-flop, definitely we need to have some extra logic circuit. That is a major disadvantage. So what is the disadvantage that you can observe by using extra resynchronizing output flip-flop? So that is, so as we are using logic gates for designing this resynchronizing circuit, so there will be some delay to propagate the signal through all the logic gates. So that is why delay is more when compared in asynchronous counters when compared to the synchronous counter. Why? Because an extra resynchronizing circuit should be used for the flip-flops here. That means an extra logic circuit formed by basic logic gates should be used in order to trigger the other flip-flops. So that is the major drawback. So that means circuit will be complex, and also the delay is also more. So that is the disadvantage of asynchronous counter. What is a Johnson counter? So a Johnson counter is a modified ring counter. So where the inverted output from the last flip-flop is connected as the input to the first flip-flop. So the register cycles through a sequence of bit patterns. So here, actually it is nothing but it is similar to the ring counter. What do you mean by ring counter? The output of, for example, we have a clock. Okay. So if you have the output is given here like this, whereas the output of the last flip-flop is given as input to the inverting input, a non-inverting input of this one. Let us consider this as T flip-flop, JK flip-flop. Let us consider this as JK flip-flop. This is JK, JK, JK. So these are the outputs, right? Q, Q bar, Q, Q bar. So right. So if the direct output last, or that is the true output of the last flip-flop is given as input to the first flip-flop, then this flip-flop is said to be ring counter. Ring counter. So here the ring counter and Johnson counter are same. Only the thing is, in ring counter the output is the complemented output of the last flip-flop is given as input to the first flip-flop, such that it can count more pulses when compared to the when compared to the ring counter. Okay, so this is Johnson counter. Now, what is a ring counter? So, ring counter is a type of counter composed of all the flip-flops connected into a shift register, with the output of last flip-flop fed into the into the input of first flip-flop, making a circular or a ring structure. That means the true output of last flip-flop is given as input to the first flip-flop, such that a circle or else a closed loop is formed. So such type of counter is said to be ring counter, as it is forming a closed loop or else a ring or a circular. So we can call it as a ring counter. Now, what is the purpose of a shift register? So first of all, what is a register? Register is nothing but a storage device which can store the data, that means which is more than one bit. So when a bit is input on the right, all the bits move one place to the left and the leftmost bit disappears. So the shift registers are commonly used in converters that translate parallel data into serial data or vice versa. So the shift registers can also function as delay circuit and digital pulse extenders. So this is the purpose of shift register. So what happens in order to shift the data? So it just stores the data by shifting the data either to the left or right. So this it finds majorly applications in the area of serial to parallel data conversion or else parallel to serial data conversion, and it functions as a delay circuit. So wherever we need to provide some delay, there we can use the shift registers. Okay, so that is the purpose of shift register. What are universal shift register? So universal shift register is a register which has both right shift, left shift with parallel load and serial load capabilities. So a shift register can be either shifting to the left, either shifting the data to the left, or else can be shifting the data to the right. If the data is shifted to the left, then we can call it as left shift register, or else if it is we are moving the data to the right, then we can call it as right shift register. If both the operations are done, then we can consider, that means left shifting and right shifting is done, then we can consider it as a bidirectional shift register. So where the data can be loaded into the shift register either serially or parallelly. Serially means what? Bit by bit. Loading the data into the register bit by bit is nothing but serial loading. All the bits of data which is to be stored in the register are applied at a time, then it is said to be parallel loading. So a register which has both right shift and left shift loading capabilities, and also the serial in and parallel in, that means serial shift and parallel load capabilities are also possible. Then such type of, that means all the type of operation that it can perform, it can load the data serially or parallelly, and it can shift the data either to the left or to the right, and hence we are calling it as universal shift register. So universal shift registers are used as memory elements in computers. So majorly in computers we have memory units, right? So all these universal shift registers are used as memory units in the computer. Now let us see the difference between register and shift register. What is the major difference between register and shift register? So both the shift register and counters are made of flip-flops, that we all know. Even a counter can be constructed using flip-flops, that means cascading of flip-flops will give you either a counter or a register. A shift register is simply a chain of flip-flops where the Q output of one flip-flop connects to the D input of the next flip-flop. A shift register will transfer the data from one flip-flop to the next flip-flop on each clock event. So that means in a normal register, it is just a register which can store the data. But a shift register is a register not only stores the data but also shifts the data either to the left or right by one position for each clock event. So this is the difference between register and shift register. What is a bidirectional shift register? As I told you now that bidirectional shift register is the one in which the data can be shifted either left or to the right. It can be again implemented by using gate logic that enables the shift operation. That means either you want to shift the data to the right side or left side, that can be enabled by using a control input. So that means I can decide in which direction the data has to be moved in the register, either to the right or left. That can be decided by an enable input. So a bidirectional shift register is a register in which the data can be shifted from right to left or left to right, and which can be implemented using logic gate that enables the shift operation. Now let us see what is a dynamic shift register. Dynamic shift register means what? So a dynamic shift register circuit comprises an input terminal and an output terminal. The logic circuit is made operative by an output signal of the signal follower and produces an inverter function at the output terminal in response to output signal of the second transfer. So that means we'll have a logic circuit and which is made operative by an output signal of the output signal follower and produces the an inverter function at the output terminal in response to the output signal of the second transfer. So that means it dynamically changes the state of the or else the data stored in the register. So that is why we are calling it as dynamic shift register. Define a sequential circuit. How can we define a sequential circuit? Sequential circuit is a digital circuit in which the output is a function of present input as well as the present state of the circuit. Present state is nothing but the previous output of the circuit. So that means present state is equivalent to previous output. So what I want to say, so the output of a circuit depends both on the present input, that means whatever the input that is applied to the sequential circuit at that instant of time, and also a clock cycle before that particular input is applied. That is nothing but previous state or else previous output of the circuit. So that means as it has to store the present state, it requires some memory element where it is to be given as feedback to the input signal, because the output depends on not only on present input but also on the present state. So there should be a feedback existing, and also a memory element is required to store the present state of the circuit. So a sequential circuit is a digital circuit in which the present output depends on in which the next state is a function of present state as well as the present input, and hence it requires a memory element and a feedback network. So that is the sequential circuit, whereas a combinational circuit does not require any feedback and also memory unit. Define flip-flop. What is a flip-flop? Flip-flop is a circuit that has two stable states and can be used to store one bit of information or else store the state information. The circuit can be made to change the state by signals applied to one or more control inputs and will have one or two outputs. It is a basic storage element in sequential logic. A flip-flop has a clock signal. So that means flip-flop is a basic memory element which can store one bit of information and which works in synchronous with the clock signal, whereas the flip-flop circuit has two stable states and and can be used to store the information. Okay, so this is a basic thing about flip-flop. So the one thing we have to remember is flip-flop works in synchronous with the clock signal and it can store one bit of information at a time. And we can have any number of inputs, either two inputs or one input, whatever it may be the number of inputs. What is a latch here? So the output of latch depends on its input. It is continuous. It continuously checks its input and changes its output correspondingly. It is not depending on clock signal. So we can also say that latch is also a memory element where it does not work in synchronous with the clock. That means it does not have any clock signal as the input, and it also, the output of the latch depends on inputs only, whereas it does not require any present state. That means at the time it depends only on the inputs, where it does not depend on the clock signal. So that is latch. What is a JK flip-flop? A JK flip-flop is basically gated RS flip-flop, the addition of the clock input circuitry. So the JK flip-flop is nothing but RS flip-flop. So we already know that RS flip-flop or else set reset flip-flop. This is same as set reset flip-flop, but only the thing is, in order to avoid the indeterminate state of SR flip-flop, we are going for the JK flip-flop. So what was the indeterminate state in SR flip-flop? When both the inputs S and R are equal to 1, it leads to an invalid condition in which both Q and Q bar are equal, where they must be complemented to each other. So in order to avoid that, we are going for the JK flip-flop, which is nothing but the gated RS flip-flop, such that the indeterminate state of RS flip-flop is eliminated. So thus to prevent this invalid condition, the clock circuit is introduced. So that is why JK flip-flop is also known as gated RS flip-flop, where we are using extra logic gates in order to eliminate the indeterminate state of RS flip-flop. So what is a master-slave JK flip-flop? Master-slave JK flip-flop is a cascade of two SR flip-flops with feedback from the output of the second to the input of the first flip-flop. So we are connecting two SR flip-flops together such that the output of second flip-flop is given as input to the first flip-flop. The master is applied with positive edge triggered clock signal. That means a positive level triggered, but due to the presence of an inverter in the clock line, the slave will be responding to the negative level. So what we are doing, we are just cascading the two SR flip-flops such that the first flip-flop is applied with the positive clock, whereas the second flip-flop is applied with the same but inverted clock. So that is master-slave JK flip-flop, because as the slave flip-flop, as a master flip-flop is driving the other flip-flop, so we are calling this as the first flip-flop as master and second flip-flop as the slave, because it is depending on the output of the first flip-flop. So second flip-flop is said to be slave, and whereas the first flip-flop, which is applied with positive clock, is said to be master flip-flop. So this is master-slave JK flip-flop. Define T flip-flop. What is T flip-flop? T flip-flop is also known as toggle flip-flop. Changes its output on each clock edge, giving an changes its output on each clock edge, giving an output which is half of the frequency of the signal to the input. So what it will generate? It will generate an output signal whose frequency is half of the signal to the input T. So the output signal frequency will be half of the input signal. That is what we want to say. So toggle T flip-flop is also said to be toggle flip-flop, which changes its state on each clock edge, giving an output which is half of the frequency of the signal to the T input. What is a clock? So clock signal, define clock signal. So clock signal is a particular type of signal that oscillates between a value high and low. So clock signal in general, we can represent the clock signal like this, where it will be varying continuously from or else in between 1 and 0. This is 0, 1, 0, 1, 0, 1, 0, 1. This is a clock signal which oscillates between logic high and logic low. This is a clock signal. What is memory cell? So memory cell is an electronic circuit that stores one bit of information, and it must be set to store a logic 1 and reset to store a logic 0. That means if the content of a memory cell is made 0, then that memory cell is said to be reset. If the memory cell is set to store logic 1, then that memory cell is said to be that memory cell is set to be, so it stores the one bit of information and it must be set to either logic 1 or reset to logic 0. if the value is maintained or stored until it is changed by set or reset process. And whenever there is a change in the input, then only it can change the state of that memory cell. So if the memory cell is given with logic 1, then it just stores the logic 1. If it is given with logic 0, it just stores the logic 0. So this is memory cell. What is a binary cell? An elementary module of computer storage that can be one or the other of two states, can thus store one bit of information. So binary cell is nothing but a module of computer storage that can have one or the other of two stable states, and it can thus store one bit of information. Or else we can say that it is also a sequential circuit which can store the one bit of information. What is parallel to serial converter? Parallel to serial converter means shift register is used in parallel to serial converter mode, which converts the parallel data into serial data. Parallel data into serial data means the input is applied. Let us consider these are all the flip-flops. All the bits of data are applied parallelly at a time, whereas the data is retrieved from the memory unit serially, bit by bit. Then such type of mode of operation is said to be parallel in, serial out, or else parallel to serial converter. Define clock skew. What do you mean by clock skew? Clock skew is a phenomena in synchronous digital circuits in which the same sourced clock signal arrives at different components at the different times. That is, the instantaneous difference between the reading of any two clocks is called as clock skew. So that means, in short, we can define the clock skew as the instantaneous difference between the readings of any two clock signals is known as clock skew. What is a sequential machine? So sequential machine is different and sequential circuit is different. Now let us see the definition of sequential machine. It has inputs and outputs that can each take on my value from a finite state and or of interest only at certain instant of time, and in which the output depends on the previous inputs as well as the concurrent input. So that means the sequential machines or the sequential circuit in which they only depend on certain instance of time and in which the output depends on previous inputs as well as the current point. So this is sequential mode. Now what is the JK flip-flop characteristic equation? What do you mean by characteristic equation? It is an equation which is showing the relation between the output parameters and input parameters of a sequential circuit. So the JK flip-flop characteristic equation is given by Q of t plus 1 is equals to K bar of t into Q of t plus J of t into Q bar of t. So this is the equation for JK flip-flop characteristic equation. Now what is serial shift register? A register is serial in parallel out. The register is loaded with serial data, one bit at a time, with the stored data being available at the output parallel in time. So that means the data is entered into the register serially bit by bit, whereas the data is read from the register parallelly, all the bits of data at a time, and hence the register is said to be serial shift register. Now what is triggering? Triggering means the output of flip-flop can be changed by a small change in the input signal. This small change can be brought with the help of clock pulse or commonly known as trigger pulse. So that means what we can understand, the output of a flip-flop can be changed by a small change in the input signal. This small signal changes can be brought with the help of clock pulses or commonly known as trigger pulses. Trigger pulses nothing but external signal which are given to the sequential circuit such that the state of the circuit will be changing. So this is what is triggering. Define level triggering. Level triggering means, always you remember, all the sequential circuit works in synchronous with the clock signal. So let us consider this as a clock signal. Define level triggering. Level triggering means, so even when the output or else when the clock signal is either at logic 0 or logic 0 or logic 1, if there is a change in the input, then the output changes, then the type of triggering is said to be positive level triggering. So negative level triggering means actually it should be 0. So negative level triggering means if the clock signal, this is logic 1 and this is logic 0. So here what happens is, in negative level triggering, so if the output or else if the input is applied between logic 1 and logic 2, so here when the input is equal to logic 1 or else when there is a change in the input, definitely the output will change. Instead of remaining in the logic 1, it will go back to logic 0. So that means when the clock signal is either logic 1 or logic high, if there is a change in the input signal, if the output is changing accordingly, then such type of triggering is called as level triggering. So that is level triggering. Now coming to the edge triggering. What do you mean by edge triggering? So let us take uh, let us take a timing waveform here, 0 1 0 1 0 1, right? So now I want to so here I want to explain edge triggering. Edge triggering means this is the clock signal. So the flip-flop changes its state only at the edges of the clock signal. So the edges may be either a positive edge or else raising edge, and second type of triggering is negative level triggering. Negative level triggering means it may be either 0 or beyond that. Then if there is a change in the clock signal from either 0 to 1 or 1 to 0, then the output of the flip-flop will be changing, and this type of triggering is called as level triggering. Sorry, edge triggering. Only when the clock is changing from 0 to 1 or 1 to 0, if the flip-flop is changing its state, then such type of triggering is called as edge triggering. Now, edge triggering is the circuit becomes active at negative or positive clock pulse of the signal. Now, coming to the next one, what is excitation table? So, we all have studied truth table and excitation table. Truth table consists of input variables. Truth table consists of input variables. So here, what do you mean by excitation table? So in case of truth table, we will be knowing the input variables and we'll be analyzing the output variable values. Whereas now, so what is happening? So what we need to do, we need to consider, let us consider this as the present state and this as the next state. So if you consider the present state and next state, and you are going to, that means if the flip-flop or else in order to make the changes in the state of the flip-flop, then what should be the inputs that we need to apply to the flip-flop will be taken from the excitation table. So means what? The excitation table is a table which gives all the possible inputs that are to be applied to a sequential circuit in order to change the state from present state Q of t to Q of t plus 1. So first we know the output present state and next state. Now based on that, we will be trying to analyze the equation for that Boolean function. So now that is said to be excitation table. Excitation table is a table in which the present state and next state are considered, and in order to take a transition from present state to next state, what must be the inputs that are to be applied to a flip-flop are derived, and such type of table is known as excitation table. Now what is SR flip-flop? SR flip-flop is an arrangement of logic gates which are cross-coupled, maintains a stable output even after the inputs are turned off. Even after the inputs are turned off, it maintains a suitable output. This simple flip-flop circuit has a set input S and reset input R. The set input causes the output of flip-flop to change from 0 to 1 and vice versa. So this is the SR flip-flop. Now coming to the D flip-flop. D flip-flop is also called as delay flip-flop. The D type flip-flop is checked with, the D type flip-flop is clocked flip-flop which has two stable states, that is D type flip-flop converts with, or else D type flip-flop operates with a delay in the input by one clock cycle, that is D type. Flip-flop is also known as D flip-flop or delay flip-flop. That means D flip-flop is defined as a sequential circuit which has two stable states, and the flip-flop operates with a delay in input by one clock cycle, and D type flip-flop is also called as delay flip-flop or data flip-flop. That means what I want to say is the D flip-flop, whatever the data is applied, the same will be coming as, or else the next state, let us indicate the next state as Q of t plus 1 is equals to D. So that means the next state is equals to the data input, and hence we are calling this data flip-flop as D flip-flop as data flip-flop or delay flip-flop. Define positive edge triggering. So as I told you that if the flip-flop changes its state during the edges of the clock, then the type of triggering is known as edge triggering. If the flip-flop changes its state with respect to the changes in input, even at the positive level or negative level, or that means at logic 1 level and logic 0 level, then that type of triggering is called as level triggering. Now let us try to see what I mean by positive edge trigger. So in edge triggering, the circuit becomes active at negative or positive edge of the clock signal. For example, if the circuit is positive edge triggered, it will take input at exactly at the time in which the clock signal goes from low to high. That means when there is a change in the clock signal from 0 to high, if there is any change in the input signal, definitely the flip-flop changes its state, and such type of triggering is called as positive edge triggering. What do you mean by negative edge triggering? So the flip-flop changes its state only when the input signal is changing its state from logic 1 to logic 0. That means it is falling from logic 1 to logic 0. So that is why it is said to be negative edge triggered. So that means I want to define one more time negative edge triggering. In negative edge triggered flip-flop, or else negative edge triggering means what? If the circuit changes its state during the when the clock changes from logic 1 to logic 0, then such type of triggering is known as negative edge triggering. And what is the characteristic equation for SR flip-flop? As we all know that SR stands for set reset. So the characteristic equation for SR flip-flop is Q of t plus 1 is equals to R dash of t into Q of t plus S of t, or else in short we can also write it as R bar Q plus S. Okay, so R bar Q, R complement Q plus S. So this is a characteristic equation of that SR flip-flop. Now what is a timing diagram? What is a timing diagram? Timing diagram is a graphical representation of input and output signals as function of time. So that means what we are going to do by using these timing diagrams, we will be able to represent the input and output signals as a function of time. Since the inputs and outputs can only take the values of zeros and one, their graphical representation are series of square pulses with a variety of time lengths. So that means in order to do the timing analysis, what should we do? The input and output can only take the values of 0 and 1, and once it is done, we can draw the timing diagram which graphically explains the functionality of that particular module. This is timing diagram. Now what are the applications of flip-flops? So we can find so many applications for flip-flop. So I will be discussing some few of the applications of flip-flop. So what are the applications of flip-flop? It can be used as data storage. Either it can be a single bit or multiple bits. So we can use this as data storage device, and it can be used for data transfer. In order to transfer the data from one place to the other place, we can also use D flip-flop, where it can provide the required amount of delay. And we can also use these flip-flops in the construction of register, counters, and even they can be used for frequency division and memory, etc. So these are the applications of flip-flops. So they can be used for storing the data and data transfer, latch, and even we can use this for implementing the designs or counters and frequency division and memory unit. So this is about the basic definitions and terminology related to the fifth module. I hope it is clear to you all. We have seen what are the terminology that we have come across while studying the third module, and I have defined each and every characteristic parameter of this each and every characteristic of this sequential circuit, and what are the different types of sequential circuits and all we have seen. I hope it is clear to you all. That's all for this lecture.
Like, share and subscribe. Hit the bell icon for more updates.